Welcome once again to Chibuzor Mathphysics. I will be taking you through length of a line and relative position vectors. You will see this in analytical geometry, and you can also see it in vector analysis. Usually, mathematics is procedural because what you learned in one unit can be applied in another unit. So the knowledge you have in analytical geometry is very much important as you are going to use it in vector analysis. So here is a question that you need to have a background knowledge of both analytical geometry and also vector analysis. In the campus, in the university, for instance, students are being asked to do analytical geometry first before you do vector analysis. But the problem comes when you are given this question and then you have not done vector analysis, but you are doing this question in analytical geometry. So let me show you what to do when you are given such a question. It could be a bit tricky, but if you follow systematically the steps, then you are good to go. So what exactly is the length of a line and relative position vectors? When we talk about the length of a line, we are talking about the line segment. It can be the distance of the line between the endpoints. So the length of a line is just the distances between the endpoint. We can talk about x1, y1, x2, and y2. So that is what we mean by the length of a line segment. So it is just the distance between the endpoint. And the position, the relative position vectors, the relative position vector is nothing but talking about the position to specify the position of a certain body. If you are in physics, you will understand this more well because knowing the position vector is actually the position of a body, and this body will be describing the motion of that body. So it is very important that these things are related. You can see that physics has some aspects to do. When you do mathematics and you do physics, they work hand in hand. So for those who are in mathematics and they are not in physics, I'm sorry, but that is the only way to go. I am going to show you how these things are related, where they are related, and how you need to combine both analytical geometry and vectors, which is now vector analysis. So let us jump into the calculation and see what we were supposed to do. Now we have the length of a line in Cartesian coordinate, and the question here says a straight line AB is drawn between the 2 points, and the 2 point is A and B, and A has both X, Y, and Z. So when you have three variables, three numbers here we have 5, -2, and 8. It means that you are having three variables. So you have X, Y, and Z. And B, you also have -3, 5, and 0 in Cartesian coordinate. And the coordinate is that of 0. You have X, Y, and Z, where the coordinates are measured in meters. Now, what we are supposed to do is to find the length of the line AB. We find the length. Remember from my previous definition, I told you that the length is nothing but the distances of the endpoint. So we'll be using the distance formula in order to find the length of the line AB. So B, we express the relative position vector. Now you can see this is relative position vector, which is more applicable when we do vector analysis. So the relative position vector is represented by R of this 2 point AB. So that's why you have RAB, this subscript AB, as a Cartesian vector. Now, number 3, we are to also to find the Cartesian form of the unit vector in the direction of AB. we find the angle between the line AB and the positive x-axis. Then finally, which is number 5, a force of 200 Newton. If you are in physics, you understand while I brought the aspect of force. So a force of 200 Newton acts along the line AB. So what is the component of the positive z direction? What is the component of the positive z direction? So let's start from number 1, how to find the length of a line AB. So to calculate the length of a line AB, we need to apply the distance formula. So the length of this point AB will be given by the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. This is simply using the distance formula. So since we're having x, y, and z, we simply need to bring in what we have. Remember, in our equation, we have the x1 is 5, x2 is -3, and so we'll be using this x1, x2, and x3. So y1, y2, and z1 and z2. So that's all we need to plug into that equation, and we are good to go. So it will be -3 and then -5. -3 is our x2 as it indicated. -3 here it is x2, and 5 is our x1. 5 is our y2, -2 is our y1, 0 is our z2, and 8 is our z1. So that's all we need to plug into that, so that we have -3 minus 5 squared plus 5 plus 2, because plus will give us minus will give us plus, and here we had negative. That's why we are having this positive sign here. 0 minus 8 squared, so that we end up with, if we do our calculation here, we end up with the root sign of 177, which will give us 13.304 meters approximately. So this is the length of that point AB, and this is our first solution. The second solution, we are to calculate the relative position vector. The relative position vector, as we were given, we know that relative position vector, that is the relative of that point A and B, will be given by OB minus OA. OB minus OA, if you draw it virtually, so that the first point we are given is 5, 2, and 8. If we go back to the question, we have 5, -2, and 8. We simply need to put them in the form of equation. This is going to be our I, J, and K, because now we are dealing with the aspect of vectors. That's why we brought in the aspect of I, J, and K. So here we will have 5I minus 2J plus 8K as our R in this position of OA. So our R in the position of OB, because 0 to the point of A, from 0, if you draw the Cartesian coordinate, you have from the 0, which is the main center, up to this point A will give us the 0 up to this point B is -3, 5, and 0, which is -3I plus 5J plus 0K. So it will be the R of B, because 0K simply means it is nothing. So we have -3I plus 5J. So then we can now represent this in the form of this equation, where RAB will be given by ROB minus ROA. So this is our ROB. -3I plus 5J is ROB. 5I minus 2J plus 8 is ROA. So now to find our RAB, we are going to use this vectors formula, so that we have using the distance formula that we got before, we know that x2 minus x1I will be plus
y2 minus y1 j and z2 minus z1 k. So you simply need to plug into this particular equation the values so that we end up with negative 8i plus 7j minus 8k, because negative 3 negative 5 will give us negative 8i. And how do we get that? X2 minus x1. If you go back, this is our x2 negative 3 and this is our x1 and this is I. For j, we have the y2 plus 2, because this was plus plus, that's why we got 2, and that's why we have 7j. And then 0 minus 8 is simply minus 8k, and this is our relative position vectors in meters. So it is negative 8i plus 7j minus 8k meters as our solution to the second question. So let us see what we're supposed to do next. We are to calculate the unit vector. Okay, to calculate the unit vector, it is always given by this formula. Since we are using R, this R cap, the cap on top of this R represent vectors. It means that this R is a vector, and we are calculating it in form of these two point A and B. So it will be given by RAB divided by the magnitude of RAB. These two slash line represent the magnitude, and when you see them, it simply means square root of that. So this is RAB divided by the magnitude of RAB. So that our RAB, we got negative 8i plus 7j minus 8k meters divided by the square root of the same negative 8 squared plus 7 squared plus negative 8 squared. So that we have this. And if we divide, because these are independently, so we need to take I, j, and k. So we have to take negative 8i divided by 13.304, which is the square root of this. And if we take 7 divided by 13.304, which is the square root of that, we will get negative 0.601i plus 0.526j minus 0.601k as our unit vector, That is the solution 3. Now we go to solution 4, which we are to calculate the angle between the line AB and the positive x-axis. And the line AB, we already know in the x-axis that we have negative 8 divided by 13.304i. So negative 0.601 is in that x-axis. So we are going to use this to calculate the angle we are looking for. But then to calculate the angle, you can call it alpha, you can call it beta, you can call it theta. So that angle, I have called it alpha so that it will be cos. To find that angle, it is simply cos inverse of that value you were given in x-axis, and the value we got was negative 0.601. So put in your calculator, cos inverse of this number will give you 126.94 degrees, and that is the angle. If you don't know how to put this in your calculator, simply if you have this type of calculator that is here, mine is FX991ES Plus Casio. So you just need to press shift when your calculator is on, press shift then cosine, and that is what we call the cos inverse. Now you put negative 0.601 equal sign, you get 126.941551. So I have taken 126.94 approximately as our angle, the angle between the line AB. And this is the fourth solution. Let us see the last solution, because the last one we have to calculate the unit vector of that line AB and then multiply the unit vector with the first component. We already calculated the unit vector, but since we are required to do that again, that's what I have done here, and we end up with these values: negative 0.601i plus 0.526j minus 0.601k as we got previously in question 4. But then we are to multiply the unit vector with the first component. Remember, in our equation, we were given the first component, and the first component was 200 Newton. They say that a force of 200 Newton act along the line AB. So what is it? What is its component in the positive Z direction? So its component, we are going to multiply that first component, which is 200 Newton, into all these that will got as our unit vector. So we will have 200 multiplied by negative 0.601 plus that minus this. But here you have to be very careful because you need to multiply 200 by this to get your I. You multiply again 200 by 0.526 to get your J. You multiply 200 by negative 0.601K to get your K. If you do that, you will have negative 120.2I plus 105.2J minus 120.2K. And this is what we are expected to do. So this is how we manipulate calculation that involves some a bit of Cartesian analytical geometry, vector analysis, and also when you are required to find a force that have acted on that object. If you do physics, you understand when I say that a certain force act on an object. Otherwise, I wish you all the best. I hope you have enjoyed this video. Do well by pausing the video and try to solve it yourself. This involves a lot of practice, and if you can do that, you'll be good to go. Otherwise, all the best in your academic endeavors. Don't forget, subscribe.